Welcome to RR Max channel. We are continuing with the reduction formulae, episode 10. I'm continuing with the problems. We'll take up another problem here. If un is equal to integral 0 to pi by 2 x bar n sin x dx and n is a positive integer, prove that un plus n into n minus 1 un minus 2 is equal to n into pi by 2 whole power n minus 1. Now here I have just said un because it does depends on different authors to give different notations, and in the question paper if you have a different notation, please use only that notation that is asked in the question paper. I have been so far using in, but this time I have just taken un so that you should know how you are going to change it. Now un is equal to integral 0 to pi by 2 sin power n sin x, I'm sorry, un is equal to integral 0 to pi by 2 x power n sin x dx. So we will take u is equal to x power n. So du is equal to n into x power n minus 1 dx. Take dv is equal to sin x dx and v is equal to minus cos x. You are integrating by parts here, uv minus integral v du, that gives you x power n into minus cos x, limits varying from 0 to pi by 2, minus integral pi by 2 into minus cos x into n x power n minus 1 dx. When you substitute upper limit, cos pi by 2 is 0, and when I substitute lower limit, x power n, that will give me 0. So both upper limit and lower limit will contribute 0 for this particular term. So now you have 0 plus n into integral of 0 to pi by 2 x power n minus 1 into cos x dx. So again you use your integration by parts. This time you will take u is equal to x power n minus 1, and therefore du will be n minus 1 into x to the power of n minus 2 dx. dv will be cos x dx, so that v is sin x. So here you substitute, there is an n outside with the square brackets, x to the power of n minus 1 sin x, limits varying from 0 to pi by 2, minus integral 0 to pi by 2 sin x into n minus 1 into x to the power of n minus 2 dx. So when I substitute limits here, pi by 2, sin 90 is 1. So for this x also you will substitute pi by 2. That gives you pi by 2 to the power of n minus 1 into sin pi by 2, which is 1. So it reduces to pi by 2 whole to the power of n minus 1. Lower limit is 0, so that does not contribute. And here you take out n minus 1 outside, so minus n minus 1 into, your integral can now be written as un minus 2. And so you bring this n minus 2 to your left hand side, you get un plus n into n minus 1 into un minus 2 is equal to n into pi by 2 whole to the power of n minus 1. That is the answer that you are asked to prove. We shall see the next problem. Evaluate. I is equal to integral 0 to 1 x square sin inverse x dx. So here what I am going to do is, let sin inverse x be t. That gives me x is equal to sin t. So dx is equal to cos t dt. Now when x is 0, you substitute, sin inverse of 0 is going to be 0. So t is 0. When x is 1, sin inverse of 1 is going to be 90. So that is t is equal to pi by 2. So now this reduces to the integral as integral 0 to pi by 2 into x is sin t. So this becomes sin square t. Sin inverse of t is t. So I have t into sin square t. And dx is cos t dt, so this is cos t dt. So your integral has now become t sin square t into cos t dt. Now we will do integration by parts. You call u as t, so du is dt, and dv is sin square t cos t dt, because when you do a substitution for sin t, you get cos t dt as t, that substitution will go in differentiation, and therefore this sin square on integration will become sin cube t by 3. So you substitute here, you get uv, so t sin cube t by 3, limits varying from 0 to pi by 2, minus integral of 0 to pi by 2 sin cube t by 3 dt. So you substitute your limits here. For t, I am putting pi by 2 and sine pi by 2 is 1. So whole cube is also going to be 1. So 1 by 3 into pi by 2. Lower limit is 0. So minus 1 by 3 comes outside. You apply your reduction formula here. N minus 1 by n. So this directly comes to 2 by 3. Since it's odd, it stops with 2 by 3. So you just take out 1 by 3 common and you get pi by 2 minus 2 by 3 as your answer. That's a simple 2 marks question. So next we shall see another problem. Evaluate integral 0 to 1 x cube divided by root of 1 minus x square dx. So I make a substitution here. Put x is equal to sine theta and dx will become cos theta d theta. So when x is 0, theta is 0, x is 1, theta is going to be pi by 2. So when you do the substitution here, you get integral 0 to pi by 2 sine cube theta divided by root of 1 minus sine square theta into cos theta d theta. Root of 1 minus sine square theta is root of cos square theta, which is cos theta. So that cos theta and this cos theta cancels, leaving you with just integral 0 to pi by 2 sine cube theta d theta. Directly apply your reduction formula as n minus 1 by n, which gives you 2 by 3, and that's your final answer. This is another possible 2 marks question. So we shall see another problem. Yeah, next problem. If in is equal to integral 0 to 1 x squared into 1 minus x cube whole power n dx, prove that in is equal to n by n plus 1 in minus 1. Hence, evaluate integral 0 to 1 x squared into 1 minus x cube whole power 7 dx. So here what we are going to do is take u is equal to 1 minus x cube whole power n, and so dv as x square, so that v will be x cubed by 3. Substitute here uv, so that's 1 minus x cube whole power n into x cube by 3, limits varying from 0 to 1, minus v du, so integral 0 to 1, v is x cube by 3, and for du you are differentiating, you get n into 1 minus x cube whole to the power of n minus 1 into minus 3x square dx. So this 3 and this 3 cancels, and we'll come back here to substitute the limits. When you put 1 minus x cubed, that term will be 0. And when I put 0 for the lower limit, because of this x cube, it will become 0. So the contribution of this term is 0 totally. So here there's a negative sign and there's a negative sign here. But I will like to retain this negative sign as it is. Minus n into integral 0 to 1 minus x cubed to the power of n minus 1. Retain this x square. Take this negative sign with this x cube, so you have minus x cube, add and subtract 1 to that. So within the brackets I put 1 minus x cube minus 1 dx. Now 1 minus x cube, you take it as one term and club it here, and 1 you retain it as another integral. So we get two integrals now, which is minus n integral 0 to 1 x square into 1 minus x cube whole power n dx plus integral 0 to 1 n into x square into 1 minus x cube whole power n minus 1 dx. So that reduces to minus n in plus n in minus 1. Bring this in to your left hand side. So that gives you 1 plus n into in is equal to n into in minus 1, or in is equal to n by n plus 1 into in minus 1. You are asked to evaluate integral 0 to 1 x squared into 1 minus x cubed whole power 7. So n is 7 here. So you start with I7. So that I7 is equal to, you are using this formula, n by n plus 1. So you get 7 by 8 into I6. For I6 you substitute, you get 6 by 7 I5. So similarly for I5 you substitute, then you get I4 you substitute, etc. So I've just done it completely here. So you get it as 7 by 8 into 6 by 7 into 5 by 6 into 4 by 5 into 3 by 4 into 2 by 3 into half, and finally it will be I naught. So when you want I naught here, I naught means this term 1 minus x cube whole power n, that will become 0. So you will just have x square term. So I naught is equal to integral 0 to 1 x square dx, which is x cube by 3, limits varying from 0 to 1. That gives you just 1 by 3. So you substitute your I naught as 1 by 3 here, and you can see this 7 gets cancelled, 6 gets cancelled, 5 gets cancelled, 4 gets cancelled, 3 gets cancelled, and 2 gets cancelled. It has reduced to 1 by 8 I naught, and 1 by I naught is 1 by 3, and therefore you get I7 as 1 by 8 into 1 by 3, which is 1 by 24. So that's going to be your final answer. Okay, let's go for the next problem. Prove that integral 0 to 1 x to the power of 3 by 2 into root of 1 minus x dx is equal to pi by 6. You are asked to prove this. Now here you have root of 1 minus x. So I will substitute x as sine square theta, because only then I will get 1 minus sine square, which I can simplify. So put x is equal to sine square theta, dx is 2 sine theta cos theta d theta. When x is 0, theta is 0. When x is 1, theta is pi by 2. So your integral I now becomes integral 0 to pi by 2 sine square theta to the power of 3 by 2 into root of 1 minus sine square theta into 2 sine theta cos theta d theta. This will reduce to root of cos square theta, which is cos theta. And here the sine square to the power of 3 by 2 will simplify to sine cube theta. So now it becomes this sine cube theta into sine theta reduces to sine power 4 theta, and cos theta into cos theta becomes cos square theta, which I will simplify it as 1 minus sine square theta. So the whole integral now reduces to 2 times integral 0 to pi by 2 sine to the power of 4 theta minus sine to the power of 6 theta whole thing into d theta. You can apply a reduction formula directly here. So 2 times, for 4 I have applied the formula. Both are even numbers, so it should end with a pi by 2. So for 4 it will be 3 by 4 into half into pi by 2, and for 6 it will be 5 by 6, 3 by 4 half into pi by 2. So you can just take out the 3 by 4 half and pi by 2 as a common factor. So 2 into 3 by 4 into half into pi by 2 into 1 minus 5 by 6. And so that reduces to 1 2 gets cancelled. 1 minus 5 by 6 is 1 by 6, giving you 3 by 4 into pi by 2 into 1 by 6, and that simplifies to pi by 16, which you are asked to prove. So let's see the next problem. Evaluate integral 0 to pi x sine power 6x cos power 4x dx. So I will use my definite integral properties here. So you can substitute your upper limit first. So I have done that. So it becomes integral 0 to pi minus x into sine to the power of 6 pi minus x into cos power 4 into pi minus x dx. You simplify this, you get pi minus x into sine power 6x cos power 4x. Actually, sine 180 minus theta, it is in second quadrant. Sine remains positive, leaving you with sine theta. But cos 180 minus theta will be negative minus cos theta. But to the power of 4 will make it positive, so I get a positive value here. Now add this I, original I and the converted I. You get 2I is equal to integral 0 to pi x plus pi minus x sine power 6x cos power 4x dx. So this x gets cancelled, giving you pi outside, integral 0 to pi sine power 6x cos power 4x dx. You can directly apply a formula here, or you can convert cos in terms of sine and simplify. So you get 2i is equal to 2 pi is there. I take the lower power 4, so that gives me 3 by m plus n, which means 6 plus 4. So 3 by 10, 1 by 8. Then you take the other number, which is 5 by 6 into 3 by 4 into half into pi by 2. So you simplify this, you get 3 pi square by 512. So let's stop here, continue in the next episode. Thank you.